Fine. So welcome to the webinar, the first webinar by GeoBits in the year 2024. And just to give you a brief of GeoBits and what we do before we start the webinar, right? So GeoBits, we act as a DBA partner for companies. We are the Microsoft certified partners, silver Microsoft certified partners in the data platform. Recently, we have also become the MongoDB partners in the technology side. So that's primarily what that's our partnership and what we do. So when it comes to our services, we have a wide range of services, writing from 24/7 DBA managed service to all types of consulting, like on the database side, migrations, HADR implementation. And these are a few of the certifications and the expertise that we hold. So we are currently managing 110 plus clients and any form of database, be it MS SQL, MySQL, Postgres, MongoDB on cloud or on-prem, we can take care of your database, right? So any type of database base requirements that you might have, you can surely reach out to GeoBits for the same. So that's about GeoBits. So thank you once again for joining the webinar. So this is our first webinar of the year 2024, and it is hosted and conducted by Neeraj, right? The topic that he'll be speaking on is unleashing performance in-memory OLTP in Microsoft SQL Server. So just to brief you about Neeraj, Neeraj is a data engineer, and so far he has done several projects on the data engineering side, be it any sort of migrations, any sort of DB related activities on the database side. He's always there to support, and he is a good and a strong support for GeoBits. So today, for the first webinar in 2024, he's going to speak on the topic. So over to you, Neeraj, and all the best.
Thank you, Joel. And, here we. Okay, we are starting with in-memory OLTP, in-memory online transaction processing. In this topic, what we are going to see are overview of in-memory OLTP and implications of OLTP systems and in-memory OLTP recommended in which area and where and how, and benefits of in-memory OLTP. And we are going to see the limitations and the implementation of in-memory OLTP in MS SQL. And conclusion. These are all the topics which we are going to see in in-memory OLTP in MS SQL. And overview. We start with the overview of in-memory OLTP.
Neeraj,
And
I think you had a slide, right?
yeah, yeah, just a minute. Yeah, now it's visible on Zoom.
Yeah, we can see. So please go
Yeah.
ahead.
Okay. Overview of in-memory OLTP. That's what we're going to see now. And the overview, the simplified overview in-memory OLTP is a specialized memory optimized relational data management engine and native stored procedure compiler. Integrated into SQL Server. In Microsoft itself, it is designed in memory OLTP to handle the most demanding OLTP workloads. In case memory optimized tables can be created with durability schema only option to avoid all logging and IO. In simplified, we can tell that that write sources can be avoided, like disk IO we can avoid, and durable it contains like durable tables and non-durable tables. That means durable tables contain schema and data, and non-durable tables contain schema only, where the rows are placed in memory are preserved after the server restart. That is called as in durable tables, and non-durable tables are not preserved after the restart. In simplified, and in-memory optimized tables and indexes. Uh, in-memory introduced concepts like non-durable tables, traditional temp tables which is stored in memory, natively compiled stored procedure, and UDFs and more like features we have in-memory optimized tables. It was introduced under Microsoft 2016 server editions. And furtherly, we go with implications of OLTP systems. In this, we are going to see the certain topics like low latency, high through output, faster response time, high efficiency, high performance, zero or no log escalation management in MS SQL through an optimistic concurrency model, better concurrency management using this. In first point, we will see low latency and high throughput and faster response time, how it works in in-memory OLTP in MS SQL. Mm, uh, Low latency and high throughput first. In this system, in this Yeah, in-memory OLTP brings several implications and advantages to database management in this low latency and the high throughput. Using this, we can we can store and process the data in systems RAM, eliminating need for disk IO operations. The absence of disk IO results in significantly lower latency and higher throughput for transaction processing, and it may faster response time. And if we move to higher efficiency and the performance, if we see higher efficiency, how it works in higher efficiency and performance, the elimination of IO waits allows for better utilization of CPU resource and contributing to overall system efficiency. With the data residing in memory, the system can achieve higher transactional performance compared to traditional disk-based databases and improved concurrency management through an optimistic concurrency model. And the main thing in this optimistic concurrency model, the optimistic concurrency model, how it works in-memory OLTP. In-memory OLTP system typically use an optimistic concurrency model, allowing multiple transactions to proceed concurrently without blocking each other. This is the where difference comes from our TeamDB and in-memory optimized thing. Optimist, Optimistic concurrency relies on versioning or timestamping to identify and resolve the conflicts during the commit phase, improving overall system concurrency and performance, which allocates some buckets in memory, and it will store the data according to the indexes which we allocate there. And improved concurrency management enables more simultaneous users or process to interact with database without sacrificing performance. This optimistic concurrency control mechanism allows for higher degree of parallelism, as transactions are less likely to be blocked by locks, or we can call as the term zero or no lock escalation management here is through an optimistic concurrency model. In this, traditional databases may escalate locks on higher level. Example, for row level or table level locks will occur under this certain condition, leading increased contention. So furtherly moving, we are going to see in-memory OLTP recommended, where we can recommend the in-memory OLTP. In-memory OLTP is designed to handle high OLTP workloads, can significantly improve performance and scalability for applications that require quick transaction processing. If database facing bottlenecks like particularly related to locking or latching while code execution, in-memory OLTP can be valuable solution. It is optimistic, concurrency model, and efficient. If there are concerns about traditional database slowing database performance, in-memory OLTP might be a beneficial one. Furtherly, we are going to see benefits. Yeah, while going to benefits, before we can see the configuration, how we have to config in-memory OLTP in our database, how we have to create the in-memory database, and how we have to create the tables in that. We can see an demo using SQL Server. By here, I'm creating a database first in the name of client. We can create a database here using the name of client. Here we can see memory optimized file streams. We have to enable this first. File. Before that, I am creating a DB here. Now we have a database called client. In this, now we have to enable the file stream groups, which enables the memory optimized transactions. Now we can see that file group is created like in memory optimized file group. Yeah, memory optimized data file stream files. This is how database we have to create memory optimized database, and we have to create the file stream for that memory optimized database. And now we can see in the memory optimized data, we have a file called in-mem1, which is databases memory optimized database, and that database contains the file stream of in-mem. You can see here on the file we are having one file stream, and using this. Okay, yeah. Using this, now we are going to create a table called student, which is a normal table in our database. In our client database, we are going to create a normal table called student with ID column of identity insert. Using client, creating a table called student. Yeah, now you can see tables. Here we created student, which is the normal table. Only ID column contains the identity insert. And after we are creating a table which contains in-memory optimized table. And this is a stable structure which we have to use to create a table with the in memory. We are using student in mem table name for creating a in-memory table using here memory optimized on durability schema only. Using this, we are creating schema only durability, which we are using. And every table, while we are creating an in-memory that contains an index. Yeah. Now we can see that student DBO student and DBO dot student in both the tables. The student is the table which contains that normal structure, and student in mem contains the in memory optimized table, which the table is stored in memory. And now we are going to create a procedure which is student normal. In the name of that, we are going to insert data into the student table. We are going to see the how much difference it will take, like in memory optimize the table, how much difference, how much time difference it will take between that normal table. Procedure to student in one we are creating. This is the procedure which is using the schema binding and the native compilation, which in memory optimized tables and procedures which we will use. And here I'm using that native compilation schema binding, which is going to insert the data into student in one. That is a memory optimized table. We are going to insert the data using this procedure using native compilation schema binding. In between time, yeah, we will see what are all the benefits of using memory OLTP. We will see and limitations. Then again, we will continue with that process. We created the procedures and how execution will happen. Like that, we will see the benefits, and again we will see benefits of using in-memory OLTP. First, these are all the points which we have that eliminate contention, minimizing IO logging, efficient data retrieval, minimize code execution time, CPU efficiency, IO reduction or removal. Eliminate contention. Eliminate contention, which contains the optimistic concurrency model in OLTP, reducing the need for locks and minimizing contentions. Multiple transactions can proceed simultaneously without waiting for locks. Improved overall concurrency. The second point, minimizing IO logging, which means tables in-memory OLTP can be created with the durability of schema only option. We can create with schema and data and schema only also, but we are creating using the durability of schema only option that eliminates need for extensive logging, that helps minimize IO operation related to transaction logging, enhancing performance. Efficiency data retrieval. With the with the data stored in memory optimized table, that enables efficient data retrieval. Memory access is faster than disk access, leading to quicker retrieval times for queries and transactions. Minimize code execution time. In this supports the stored procedures and the codes are natively compiled and reducing the execution time of queries and operations. Compilation at the time of creation enhances the speed of subsequent execution. And CPU efficiency. Eliminating of I/O waits and optimized data structure contribute to improved CPU efficiency. In-memory OLTP is designed to make efficient use of CPU resources and enhancing overall system performance. Here, I/O reduction or removal. In-memory OLTP significantly reduces or eliminates the need for traditional disk I/O operations. Data is stored in memory and leading to reduction in I/O related bottlenecks and improving overall system efficiency. And we can see what are all the limitations we are facing in this in-memory OLTP. Limitations, and these are all the limitations. While we discussing this limitation, table should have at least one index. Yeah, before I told while creating the table, we need at least one index which a memory optimized table contains. And no concept of heap. And except for an application lock, in-memory OLTP does not have the ability to lock records like standard SQL queries, and memory limitations are there. While doing this, in-memory OLTP requires memory optimized tables to have at least one index. This is the mandatory requirement for the table structure, and tables without indexes are not allowed. No concept of heap. Does not support the concept of heap table, which is a table without any clustered index. All memory optimized tables must have at least one index defined. Inability to lock records. Limitation. In-memory OLTP does not offer the ability to lock individual records like transaction server queries, the optimistic concurrency, and except for application level locks, there is no direct record level locking mechanism. And this process relies on the system memory for storage. While this provides high performance advantages, it also means that the most data that can be stored in memory is limited by the available RAM. Large data sets may face limitations due to memory constraints. While it offers significant performance benefits, there are specific requirements and restrictions that need to be taken into account during the design and implementation phases. Understanding these limitations is crucial for making informed decisions about when to leverage the in-memory OLTP database environment. And yeah, we will get back to our demo session, which we are doing created the stored procedure last. And now
Neeraj, are you speaking anything?
Trail Pro, I'm doing that table.
Okay,
Yeah,
okay, fine.
yeah,
Yeah.
yeah,
So he's executing, guys. So he's audible
yeah.
only. Yeah.
Yeah. Now what we done? We just created the stored procedure, and we are going to execute the stored procedure using that OSTress, which I am using here as an application like users going to connect using this SQL file. Now I am using OSTress, which my file name is student, I think. Yeah, which my which my file name is student. And here I am using Hostess, like 25 users is trying to insert data into the student table, which is not memory optimized with that iteration of 50. That means each user trying to insert 50 data per execution, like that we are going to do. Yeah. Now you can see my activity monitor here. We don't see any database IO or process times or wait time. Is nothing is there in wait time. Also, you can't we can't see anything. Everything is normal in the SQL side. Now we are going to insert data into the normal table, which is the student. Oh, yeah, student.SQL. 25 users, 50 iterations is we are doing. Now we can see one row is inserting into the table. Here we can see right log is network IO and the write types like here, and database IO is getting high here, and page latch we are getting this kind of write types we can see while doing insert if it is a normal table using the procedure. Page latch ex, these are all the write types which means SQL server is waiting for the page to write in our disk IO. Every data is inserting.
Sorry, Neeraj, your screen not visible. Actually, the screens are not moving.
Yeah, just a minute. Now it is
Not yet, Neeraj.
yeah, Joel bro. Now it is
Yeah, we can see now. Yes.
yeah, yeah. Now we can see page latch and page IO and asset network page latch ASH, which means SQL Server is trying to waiting for the page. Every insert it is trying to write on the every page, and it is waiting for one another to move with each other. Now it is done. Yeah, we will check how much time it took. Yeah, it is the normal table. It took approximately 1 minute 43 seconds, 165 milliseconds time to finish this process. Around how much data? We'll see that also. It was around 1 crore 25 lakh data we have inserted into this within 1 minute, 1 minute 43 seconds. Using that means 25 users trying to insert this data every 50 times. So we got that page latch and page IO. Now we will see how much time it will take for in-memory optimized table and how it will react here. Student in, okay. Same thing. Now we are doing with the in-memory optimized table. 1 minute 43 seconds. We check to the step. Now in-memory optimized table, how it is inserting, we'll see. Only process time. Our memory will get to this, and that's it, I think. Yeah, and within 10 seconds, which is that normal table took around 1 minute 40 seconds. Now here using that memory, we have inserted around 1 crore data within 10 seconds, 207 millisecond. We can see that also. Yeah. Yeah, the same kind of data within 10 seconds. This is the difference between our in-memory optimized table and the procedure and the normal table and the difference between the procedures and all. Which is writing in disk is it takes so much time while it will wait for the page, and so only we are getting that wait type of page IO, page latch and latch EX. And if we using the memory, we don't get anything like that. It will process the whole data in memory and it will optimize. So Joy bro.
Uh, yes,
Yeah.
Neeraj, thank you for that. So guys, do you have any questions? Any questions,
Yeah,
any doubts that you
sorry,
have for Neeraj? Yes.
I've joined late. Okay,
Yeah, Joel, yeah.
yeah,
Please go.
yeah. This in memory insertion which you're showing, this is available from which version? So,
Uh, which position in essence is one? I'm not getting it.
SQL Server,
Yeah. SQL Server, yeah,
yeah,
Microsoft SQL Server.
which DB version?
It was around 2016 it is supported.
Okay,
Yeah.
so are you going to send some write-ups like documentation kind of thing, or
Yeah,
to
we'll,
enable this, or
yeah,
on the our WhatsApp chat?
yeah, we'll discuss about this if Joel Bro will connect with you shortly regarding this.
So what we'll do, Ifran and even Rajashekar, you guys have asked in the chat. So what we do is we record these sessions and we upload it on our YouTube channel, the GeoBits YouTube channel. So all our previous webinar, along with this webinar, in maybe 2 or 3 days will be uploaded. So we can revisit those videos and have a look at it as well. So
Perfect, perfect. Yeah.
anything that you missed, you can get it from there.
Mhm. Even the previous
Yep.
this one we can see, right? For
Yes.
performance tuning and any other things.
Yes. That's right. That's right. All the
Excellent,
previous
excellent.
webinars that we have done, it's there. So our YouTube channel name is Geobits.
What is the name?
Geopits.
JO?
Geobits. Geopits.
Is J for
G for ground.
Geo.
Yeah. Geobits. Pits. It's there in my screen also. Right there. So
Okay. Mhm. Thank
thanks, Infran, for that question. Anyone else? Any other questions? If you put the full name as Geo Platinum IT Services also, you'll get the same. It's either GeoBits or you can put in Geo Platinum IT Services. Neeraj, I think we have one more
Yeah,
question in the chat. How about what about updates? How will it work?
yeah, it's like a same like a insert linking. How we are inserting the same like that only in update also. We can try that using here I used the Ostras with saved in .sql file and we executed. But in update we can directly it can call like how application will call on query na, like that it will call directly. But it will same like that only. If like how na if we are it's writing update also it will make some update also it will make some table level or row level log while doing this, but in memory table we are using now while update insert or delete which didn't contain any table level or row level log, which it will allows the multiple threads to write the table. So update also have that if it is a normal table now, if update also it will wait for some page or like page latch or page IO like that it will wait on some because of that lock.
But during this insert, okay,
Yeah, yeah.
if application or sorry, if database crash or is not committed to the transaction because it is in the memory.
Yeah,
So
we
is
have
there
that.
any,
Yeah, it's fun. Yeah, it's fun. Yeah, I understand. We are using the durability here, like schema only and schema data and schema like that. If we can take the backup of using the database backup, we can bring the data. And if we use that data and schema only durability, na, we can get that data also, and we can take that backup of files like file stream we are creating while configuring that in-memory OLTP to databases. Na? In that time itself, we can take a backup of file stream. Using
Mhm.
that file stream also, we can bring back that data.
Mhm.
Yeah. If the server is going down, it will automatically write the data to the files.
So, but is it required? It is a must, like from the day one, we have to configure everything in memory, or once we set up and the application is behaving
No,
on
no,
the, instead of
no,
doing
no,
the
no.
partitioning, we can go for in memory for example, my insert operation is slow and I'm running
Okay,
the bulk transaction. Okay.
okay, okay,
If I want to like to streamline, I mean to make it process fast, okay, for improve
okay,
the performance.
okay.
So shall we enable on ad hoc basis?
Yeah, we can enable using the table basis level. Oh, if we have to enable from database first. After that, we have enabled that in-memory optimized tables. Like if you want this table, like particular tables, we can enable using like if you are using that particular table like sales order, that particular your table using for more transactions is having the table. Now we can enable for that table only. Like that
Mhm.
options we have in-memory OLTP, which table can have the more transactions. Like that
Mhm.
we can enable that if the table
Okay.
does not contains, and if you are using joins like that we can enable that in memory optimized tables and stored procedures which is natively compiled inside the memory, like that we can do no issues.
But this is only for OLTP insert update, not for select, right?
Select, that's not an issue because there is a no lock. It will happen like that now. So select and all, no issues. We can. It
Yeah,
will
we can put
automatically
no
get.
lock or something.
Yeah.
Fine.
Yeah, for update, delete, and insert these kind of things happening, the table or row will be locked for some particular time. So it will wait for another thing to come process.
Mhm.
So it will wait for some processes to write on the page, like that of thing. So
Mhm.
only for that only this is a good for enhancing the performance. That's a good idea.
Mhm.
Yeah.
Yeah. And
Yeah.
usually we are getting, thanks for your session, is great help for us. But usually we are
Okay.
getting this kind of information 1 hour or 1 day. At least we should get it at least 1 day before or 2 days before. Okay, you are going to have this session. Okay, the problem we are, for example, uh, we are missed sometime the WhatsApp to see, so we are missing this session.
Yeah, Irfan. So what we do is at least a week prior, we inform through our LinkedIn page. So if you have a chance, you can like and follow our LinkedIn page as well, so that you will get these updates beforehand, and you can
Mm.
block your time in the calendar. And we even send a registration link where you can register, so that we send the meeting link at least 1 day prior to the actual date. Uh,
How
so.
can we register?
There's a registration link which redirects to our website for registration, but it changes from webinar to another webinar. So you can follow our LinkedIn page. That is the best way to keep these webinars up to track. So usually what happens is every month end we'll have one webinar. So it will be great if you can follow our LinkedIn page or
Yeah,
even
can
Instagram also we are there.
yeah.
Yeah, you can check us out there as well. The WhatsApp
But
group, I think
can
you
you share
belong.
the LinkedIn link, please?
Yeah, sure. One
Mm.
second.
In WhatsApp or something, so we can add you and follow up.
Yeah, I'm not sure which WhatsApp group you belong to, but I'll just share it in the chat here, the
Okay.
Teams chat. Yeah. Meanwhile, Neeraj, I think there's one more question. You can just address that as well.
Yeah. Is there any memory
Uh,
limitation for per table like it says? Yeah, Venki. We don't have, it depends upon memory. Okay. How much memory we are using, RAM. It depends upon RAM, how much we are using. And there is a no specific size like this for table. For this table, like this much memory, like have to be allocated or any limitations for table like that. There is nothing like that. If your memory is capable, like how data will store in memory in this memory optimization, there is a bucket, and with that in that bucket it contains the index. Using that index, and it contains the timestamp, like this time this thread is going to write in this timestamp, like that it will store the data there. So if your RAM is if your RAM is capable of storing the data, then there is no limitations there. Contains a bucket. Using that bucket, the data was aligned there.
yeah. Any other questions? Anyone? Okay, if not, I think we are good to close. So keep a lookout. Uh, yeah, I think it's a follow-up
I'm not able to see
questions.
the sorry. I'm not able to see the chat. I'm getting error.
Okay. Um, can you at
Cannot
least
get
type in something in the chat?
no. Cannot get your conversation. I don't know why. I
So
can
what you
tell you
can?
the SQL group. Okay. This
Okay.
is you already sent it on this group SQL DBA Hub only tech post.
Okay. I think is it a WhatsApp group or a LinkedIn group?
WhatsApp group.
Yeah, I think I'm not a part of it. So I think what you
Mm.
can do is maybe if you can just send an email with a short message of your phone number or something to that email, then I can reach you out after this call, Imran. So you can
Okay.
just with your number, you can just message email to Joel, Joel, that's my name, at
JOE.
geobits, Joel at
Mm,
geobits.com.
at Geopit.
Yeah, Geopits,
Mm,
geobits.com. So what I'll do is once I get your number, I'll call you and then I'll share on my personal WhatsApp itself. I'll share you the LinkedIn page of GeoPits, and there you can like follow the page and even get some registration links for the next webinar so that you don't miss out.
excellent. Excellent. Perfect.
Uh, Neeraj, I think it's a
Yeah,
follow-up question, right? Yeah.
yeah. What will happen at disaster? Yeah, at the as before addressed, while the time of disaster, while the time of disaster, we have the backup, right? We can use that DB backup itself because the DB itself enabled the memory optimized data, and we can take the file backup, that file stream which we are using now for in memory which we are creating now, that file backup, using file backup we can get the data, or else. Or else we can use that uh, we can use the durability level. We have to use that durability level, which means that contains schema and data only option and schema only option, which we use data and schema now. Using that disaster period also, we can that while the server is going down, it will go and write the data to the file stream.
Okay. I think we are good. So Neeraj, want to thank you for your wonderful efforts towards this successful webinar. So you
Thank
can
you.
also reach Neeraj on LinkedIn as well if you have any follow-up questions on the same. And also reach out to GeoPits for any of your database requirements, right? You can visit our website. There's a contact us page. If you just drop in a message in the chat or even email to us at info@geopits or sales@geopits.com, we'll be happy to reach out to you for any of your database requirements and we'll be able to solve your requirements as well. So thank you everyone for joining, and once again, do follow our LinkedIn page and our YouTube page for any further updates on the next upcoming webinar. This webinar will also be there on the YouTube channel as well. So don't forget to like, share, and subscribe as also. All right, looking forward to meeting you all in the next webinar as well, and invite your DBA and other database friends to join these webinars as well. Thank you everyone, and have a very nice day. Bye bye.
Thank you. Thank you.